Unmuted.
So I got muted during that. I'm not sure who heard me. But again, my name is Mike Cope with Hurco, and I'm going to be monitoring the chat today. So if you want to ask a question, put that in the chat section, and I'll read those to Jason at the end. So at this time, I'm going to turn everything over to Jason Falk and let Jason go on with the webinar. Jason?
All right, thank you, Mike. For those of you that are just logging on, we will be recording this, so please keep your microphones muted unless you need to speak, and use that chat window for any questions. So thanks, Mike, and I'd like to thank everyone for taking the time to join us here today. And Mike, can you confirm that we are recording now?
Yes, we are.
All right. All right, so we will go ahead and get started. This is our second session in these Hurco Quick Online Training Sessions. We chose to do the miscellaneous data blocks for this session. Kind of the thought process behind that was there are a lot of data blocks or a lot of features inside this area. And because it's not something typically used to create geometry, this area is often overlooked. Usually you've already created something and you're kind of fine tuning it or creating a very specific application. So there's a lot of really powerful things in here, and it's pretty common if you hear or talking with someone about conversational programming and they start to say that they just don't have the control that they feel like they need. A lot of that sits in this miscellaneous data blocks area. So usually we'll kind of go over that, and that will alleviate a lot of those issues and things that they think they don't have control. So very similar to last week, I've got a program already created, and we're just going to work through this a little bit and show you how we can take a simple program and then use the miscellaneous data blocks to kind of fine tune the way it runs to get a little bit more efficient program. So we'll just kind of go right into it. I'll start off by showing you what we're doing so we're all on the same page, and then start to modify that. So we've got a pretty simple part here you can see. If you want to take a look at the print, some of you may be familiar with this. This is one of our training prints. Because the part is already created, we're not going to need a lot of these dimensions. So this is just kind of for reference for now. So we'll primarily be spending all of our time right here in the WinMax desktop software. And for those of you that may have not been at the last session, the desktop software that I'm using is something that we can get to if you would like to try to use it.
Jason,
just let us know. Yep.
your screen is not visible.
Okay, yeah, something.
Jason?
Yes.
Okay.
The meeting software has just changed. I can't even find where I can share now. Give me 1 minute here.
Hit the go to meeting icon down on the bottom of the screen, the little orange. That should give you able to share your screen.
All right, I believe we're back up and running. Sorry for that brief delay there. Mike, can you verify that you can see the screen?
Yeah, you're good to go now.
All right. So we do have this program here, and I'll show you what we've got. If I go into the review screen, just a pretty simple program. We've got a frame that we use to cut on the outside of this. Then we have a frame that is a pocket, this small little shape over here, an ellipse, and then a couple circles. So you kind of see the order in which this part was cut. And if I'll slow down my graphics so you can kind of see what's going on. Again, this is a completed part. If we were to run this program, we would get a complete part, and it should be what we're looking for. But now we're going to change things to run a little smoother.
Jason, we're
Yes.
looking at Danny Brewer's screen now. I don't know how this keeps getting changed. So your screen is no longer being shared. There we go.
All right. Well, if I get going too far into it, Mike, and I'm on someone else's screen, just let me know. But I'm just going to start to optimize this program a little bit. The first thing I want to get into is our change parameters block. When you start working with a conversational program, it becomes pretty evident that there are times where a single parameter set may not be enough. And we're talking about the parameters that are generally under your program parameters. You know, if we take a look at the part that we have here, right now, you know, we'll cut the part, but, you know, I'm straight plunging everywhere. You know, since I do have the ability, I would kind of prefer to go into my milling tab and then just set that to a helix. If I go ahead and draw my part now, I will be helix plunging, but you also notice that I'm helix plunging out here on the side of the part where I don't really need to. So I'm kind of wasting a little bit of time out there. So I think what I'm going to do for now is I'm going to leave this set to straight plunge. And I'm going to go ahead and show you how we would change our parameters for different data blocks in this program. So the first thing that I'm going to change for this original set so that I'm not plunging out here on my stock is I'm going to make sure I increase these blend offsets. So if we go in to do that, I'm simply going to go into my blend offset, and I'll go ahead and increase both my blend offset and my blend overlap, make them a little bit larger, let's say a ½ inch. So now when I draw this, it should look a little bit better for this outside plunge, but still not giving me the helix that I want here. So now we're going to go optimize for that. If I look at my review screen, we cut this frame on the outside first, and the way I got the 2 passes there was I just took a pretty large finish pass. That's why you're seeing the 2 passes, but only 1 outside frame here. So what I want to do is I somehow want to change my parameters in between this mill frame and this that is on the outside and this mill frame that is a pocket boundary. So to do that, I'm just simply going to highlight my block number 2 here, tell it I want to insert a block before, and we're going to go into the miscellaneous data blocks. This is where we're going to be spending all of our time here today. And you should see one in the F3 spot that says change parameters. So we will go ahead and insert that into our program. And the main thing that I want to change here is my plunge type. So if I go into milling 2, I can set my rough type to helix. And I can also go back in and shorten up these, the blend offset and the blend overlap again. So if I were to draw this now, I'll speed up the graphics a little bit. You can see out here, I've got these straight plunges on the outside. And then when it comes in here for pocketing, I'm now doing the helix plunge. So I'm no longer locked to a single plunge type for the entire part. So that is one of the main uses for the change parameters block. There are several in here. And you see a block number. it's real easy. You're so familiar with where those parameters are. It's real easy to insert this block in your program, and then just out of habit, go over and hit your program parameters soft key. Well, if you do that, I'm now editing my original set of parameters and not that change set that I put in there. So the way this is going to work is it's going to go off our original set of parameters until it gets to this change parameters block, and it's going to go with that parameter set from that point on or until we change it. So we will probably go ahead and add some more of these here in just a few minutes, but that is the change parameters block. Basically allows you to change parameters for the data blocks that are coming up. For those of you that have spent some time in the program parameters or taking any of our training classes, one of the examples that I always give is if you're using a key seat cutter or a dovetail cutter, something that has some undercut to it. In our parameter set, we have a parameter for interrupt cycle Z retract. For those of you that know the interrupt cycle, when you press that, it's going to retract the head. Well, if you are using a center or a undercutting tool, that's not necessarily a good thing. So anytime I'm going to use a tool like that, I will put a change parameters block directly before the block where I'm going to use that tool. And then because I use my interrupt feature so often, I will then put a change parameters right after it to turn that interrupt function back on. So that's a change parameters block. We're going to use that at least one more time in this presentation. So just know that that is available to you. And again, just kind of a little bit of a caution when you are using it, make sure you see the word change at the top and you're in a block, an actual data block in the program. So that was the change parameters block. Let's continue to kind of manipulate this part. Let's assume that we're going to have somewhat of a production run on this, and maybe we want to set up a couple vices in our machine so that we can, every start cycle we cut 2 parts rather than 1. There's a couple different ways we can do this, and the method we're going to show you first here is the change part setup. To use that, I'm just going to go towards the end of my program here. I'm going to insert another block. Under miscellaneous, we're going to choose a change part setup. This was the kind of the change part setup that we've always had. There is a new feature called work offsets, which we're going to go over a little bit later. But for those of you that may be familiar with like the Ultimax style machines or our older machines, this is kind of the legacy method of changing your part setup or calling a different work offset. So we'll show you how to use this, and then a little bit later we'll show you how the work offsets differs just a little bit. So what I'm going to do, you notice that block number 7 in my program now looks very similar to my part setup screen. It essentially just took my part setup screen, embedded it right in the program, and now we can change these numbers. Since I don't have a machine here, I'm just simply going to add 10 inches to my work offset. So I've essentially, very similar to the change parameters, we went off our first part setup up until we get to block 7 in the program. Now I'm going to use a different work offset or part setup. So I'm going to go ahead and copy all of these data blocks so that I can put something in that new work offset. To do that, I'm simply highlighting the first block in the program. I'm hitting Shift on my keyboard and then selecting the last block. I can go to the multiple block functions, tell it I want to copy those blocks. And then when you hit paste, it's always going to paste in front of the block you're sitting on. So I'm going to highlight end of program. And we will paste those at the end of our program. When I go to draw this, one thing you're going to notice right away is at first we may not be seeing anything. If I zoom out a little bit, you'll see that that part is there. Whenever you use multiple work offsets or different part setups, your stock geometry is not moved along with that secondary work offset. So typically what I'll do, and especially in a case like this where I've already proven out the part, is I will go ahead, leave my stock geometry on for the first part, and then when it comes time for the second, I'll either turn it off or I'll go back into that stock geometry. Two different parts, it's just going to make it look like it's in one piece of material here. So now you can see we've got two of the exact same part, one in one work offset or part setup and one in the other. Now, for those of you that are watching the screen closely, you may notice that something has changed. If we zoom in here, you'll see that where we once were using a straight plunge, we now have a helix. If we go to our review screen, we should be able to figure out what's causing this. If we look at what we've done, up here in block number 2, we added a change parameters block to turn it on to helix. We then went through all our pocketing routines, we changed our part setup. Well, now we're cutting those original outside frames again, but we're still going off the parameter set that was in block number 2. So if I want a straight plunge out here like we did on the first one, I just simply need to go in and change those parameters back to a straight plunge. So we'll go ahead and insert a block right before this part setup. Just insert block before, miscellaneous, and change parameters. Whenever you insert a change parameters block, it's going to give you an exact copy of whatever your default parameters are. So if I go look through here, we should see that I am straight plunging with the larger blend offset and overlap. So if I draw this, it should look more like what we're looking for. So now we have two of the same part being cut and let's say two different vices here. If I slow this down a little bit, now that we've showed you how to use the part setup or change part setup, we may want to do something a little bit more to optimize this part now. If I go ahead and draw this, if you kind of pay attention to the tools that we're using, you'll notice that the way this was programmed, we're switching tools kind of unnecessarily here. I'm using the larger tool to do this outside frame in the pocket, and we're switching to the smaller tool for this ellipse, and then we're going back, I believe, to the larger tool for these circles. So I can either go in and do a lot of copying and pasting and reorganizing of my program, or I can use another feature of the miscellaneous data blocks, and that is tool optimization. So we're going to use that for this particular case. Tool change optimization is a 3-part process. 1, you have to turn it on. 2, you have to turn it off. And then in our program parameters, we have another toggle where we can turn it on and off to make it easy for the operator to easily enable or disable your tool change optimization. So in this case here, I want to optimize my entire program. So I'm going to go to the first block in my program. I'm going to tell it to insert a block before. Again, we're going to go into miscellaneous, and we're going to have to hit more a couple times to get to it. And I am going to turn on my tool optimize with a tool optimize on data block. When you do this, you'll see that there are 2 parameters in the tool change optimization block. We're going to ignore these for just a second. We'll get the optimization on, and then we'll explain what those do. So step 1 is complete. I've turned on my optimization. In this case here, I want to optimize the entire program. So I'm going to go to the end of my program, insert a block, miscellaneous, and tool optimize off. Now, since I am doing the entire program, if you're on a modern version of software, the tool change optimization off is kind of unnecessary, but it's still a good habit to get into to turn it off. Most of the time when you're using tool change optimization, you're only optimizing a short section of your program. So if I look at the program, I've turned on the optimization at block number 1, turned it off here, which is now block number 16. If I want to see how this is going to cut, I could go ahead and draw this. If you see, you notice we're using the large tool there. Now we're over on the second part. And now you'll notice it comes back and does the ellipse. So it optimized out those unnecessary tool changes. If you don't want to rely on your graphics for that, we can go into the program. When you're in your program review screen, we have the part program tool review and then the tool change review screen. So this shows us what tools we're going to use. And then if you continue on into the tool change review screen, this will show you the order in which these tools are going to be used. So right now my tool change optimization is turned on, and you can see I'm bringing up this tool 98, this end mill, and I'm using it for all these different data blocks. And then I'm coming down, I'm putting in tool 99, which happens to be another end mill, and then I'm cutting these data blocks here. To see what this would look like unoptimized, if I go back to my program parameters, you should notice in your General 2 tab that we have a tool change optimization, yes or no. This gives the operator a very easy means of going in and turning off the optimization. Let's say, just for example, that you've programmed a whole bunch of, let's just say, drilled and tapped holes, and then you optimized it after the fact. You know, maybe you've got some patterns and that kind of stuff in there. So you want to eliminate unnecessary tool changes. Well, you could very easily just turn off your optimization, let the control or the machine go ahead and complete one of those features, gauge that feature, and if everything checks good, you just come back in and turn on your optimization. That's kind of why we have this easy flag here, or this easy toggle to turn it on and off, just to make it a little easier on the operator so you're not deleting any data blocks. But if we look at this in unoptimized form, again, I go to my review screen, part program tool review, and then tool change review screen. It's going to show me the order that these tools will be used. So right now I have tool 98 in. Looks like it's going to cut a couple data blocks. Then we pull up tool 99. It's going to cut a couple data blocks. And then we put 98 back in, and then 99. So definitely see that it has some unnecessary tool changes here. Just by going into my parameters and turning that back on. Go to that tool change review screen. We have, again, optimized our program. So now we've got two parts in the machine. We are plunging everywhere we want. We're changing parameters the way we'd like to see it. And now we've eliminated unnecessary tool changes. So we're getting about to the part where this setup or this part would be ready to go. I want to add a few more things to it. Assuming that we're going to be cutting many of these, maybe I want to go ahead and turn on my wash down at some point in this program to make sure that these chips or swarf, depending on where you're listening from, are being washed away, and I don't have to spend a lot of time at the end of the day cleaning up. So to do that, again, in the miscellaneous data blocks, we have a function to do that. And I think I'm just going to turn it on down here when we switch to that second part. So I'll just come to my part setup, insert a block before, miscellaneous, and again, or I'm sorry, in here I'm going to go into my machine functions. The machine function is simply a method to allow you to input M codes into your conversational program. So whatever it may be, you'll notice that there's many options listed here. Some of these are machine specific, so they don't necessarily work on every machine. And we do have some auxiliary outputs in here as well, like the M52 through 55, and we have some auxiliaries as well. So if a service tech was in, and let's say you had a pallet changer, and they had told you that they wired that to your M52 auxiliary output, if you were programming conversationally, this machine function is what you would use to come in and call that pallet change or that auxiliary function. So what I'm looking for here is the wash down. It looks like an M68 is my wash down enable. So I'll just go ahead and turn on my wash down here. And then just so it's not running all the time, you'll notice that in my program, it tells me it's enabled. I'm gonna go turn it off so that it isn't just running all the time. So just before this optimization, I'll insert another block, miscellaneous, machine function, and I'm gonna go ahead and turn off that washdown, which was a M69. So if I look at my program, once we go over to the second part, I am turning on my washdown and then disabling that washdown when we're done with that. So my washdown should run about half the time that this machine is running these two parts. So again, the machine function under the miscellaneous just allows you to call any M code that is needed. Any M code that you would typically use in your G code programs can also be used in that conversational machine function as well. So I want to add one more data block, at least to this here, or at least one more. Let's say that we're on maybe on one of our smaller machines where the table comes real close to the doors, and I'm a little concerned with my vise handle. You know, if it gets left in the vise, there's a good chance it could hit the front door. You know, maybe I have it hanging off the front, but I want to make sure that I put something in this program to remind the operator to remove that vise handle before they run the program. So I'm going to come up here to my block number 1. I'm going to insert another block, go into miscellaneous, and the block that we want here is the comment block. This is a really useful block. Once I insert this, you'll see it has just a few parameters here, but this allows us to pass any type of information we want onto the operator. The most important thing to make note of in the comment block is this very first question. Is this comment a stop block? Yes or no? If you leave this at no, it's just going to display your message on the screen for however many seconds that you have displayed here. The machine will not stop and wait, it's just going to display a message. Well, in this case here, I want to be sure that that operator has removed that vise handle. So I'm going to go in and say, yes, I want to make this a stop block. That means that this machine will not go on until the operator physically hits the start cycle button. So it requires some input from the operator. You can see we can also make it an optional stop. So it's going to look at your optional stop button, see if that's on or off to see if it wants to stop. I'm going to go ahead and make it a stop block. And I'm just simply going to say remove vise handle. So once I put this in, it's a little hard to show on the desktop software, so I have a screenshot down here on the machine. When you go to run your program, this was taken off a VM10. When you go to run your program, it's going to display this message on the screen. You can see here's the runtime comment. It's giving us the comment or telling us to remove the vise handle. You'll also notice over here to the left, it's telling us to press start cycle for the next cycle or to continue on. So once this message is displayed, as long as you have that comment block set as a stop block, it will not go on until the operator presses start cycle. This can be a very useful method for many different applications. I know in the past we had an application where we had a vacuum table on the machine. And you know, when you're getting into more production, it's real easy to overlook things. So we actually use the comment block in our program to kind of reinforce the operator to double check that the air was turned on and that vacuum truck was, or that vacuum table was on and the parts were being securely held in the machine. So anything you need to pass on, the comment block can be an extremely helpful tool for that. So now we have a comment block at the beginning of our program, making sure the operator removes the vise handle. The only other thing I may want to add to this program, once we get to the end, you know, I may choose to run this kind of lights out, you know, maybe my last part of the day, I'm going to go ahead and get started and let the machine run while I'm going home. And I typically don't like to leave tools in my spindle just sitting. So I think I'm going to add a block at the end of this program to tell it to get that tool out of the spindle. So I'm going to go to the end of the program. I'm going to do an insert block before, again going into miscellaneous. And if I hit more a few times, we should see a tool change block. So in the tool change block, you just simply tell it what tool you want to bring up. In this case here, I want tool 0. I want an empty spindle. And then you're going to set your action. Do you want it to do the tool change or just prefetch the tool? Now, for those of you that have been running Hurcos for a while, you know that regardless if you're running a conversational or NC program, our control is automatically going to prefetch that next tool anyway. It's always looking ahead. It'll have that tool carousel set and ready to go so that when it calls up the tool change, you don't have to wait for that carousel to index. The only time this may not happen is at the end of your program. You know, I could go in here, give it whatever my tool number is that we're going to start with, tell it to prefetch that tool. And then if I knew that I was going to leave the machine sitting overnight, I could also then add a block to tell it to bring up tool 0 and just do a tool change. So just another option that we have here, if that is something that would prove useful in your parts. So in this part here, I think we've pretty much got this one optimized for what we'd want here. Not a whole lot that we can add into it anymore. So we still have a few more features in these miscellaneous data blocks. So I've got a couple other programs we're going to work with. And the next thing that we'll deal with is a scenario where maybe I'm doing a first and second operation in one program. So if I hit the review button on this next program, you'll see that I've got a couple data blocks, and then I have a comment block, which is telling me to flip over a part and push it against the stop. And then I've got some more data blocks. So this is a kind of a 2-op program where I'm prepping the stock in my first operation, flipping it over, and then completing the part. However, I'm doing this all in one program, so I don't have to mess around with constantly switching programs in and out. Well, if I go to run my graphics on this part or verify this part, speed these up a little bit, you can see that it's getting a little cluttered. We got stuff from both operations on the screen here. Not so bad for verification, but when you're first working through it, you know, you may want to get rid of some of the stuff to help keep it a little bit more cleaned up for you. So what I would typically do is I would leave my graphics on until I got to the point that I was happy with my first operation. And then what I would do is go into my program. I'm going to insert a block. Again, go into the miscellaneous, and I'm going to turn my graphics off. So if we look at my review screen, if I hit draw now, I should get nothing because I've turned off my graphics for this entire part. I then just go in, again under miscellaneous, and I'll turn my graphics back on right where the second op stuff starts to work. So now when I hit draw here, you can see all I have on the screen is just my second op. Everything that was done in my first op when the block was flipped over is now turned off. So the graphics on and off, pretty self-explanatory, but they can be pretty useful in this type of application. So 2 more blocks there that you may not have known were available to you. Now let's go talk about the work offset. So earlier we used a change part setup in order to set multiple parts up in our machine. Now I'm going to show you another way to do it. This is kind of the new enhanced way of doing this. For guys that are used to G-code programming, this is nothing more than what you would do by calling a G54 or G55 in your G-code program. Well, we now have the ability to do that in a conversational program. If you take a look at this program here, we have a very simple part that we're creating. Just has a couple holes in it or circles, but you'll notice that I'm doing it in different locations. And I'll just go ahead and get rid of these other data blocks and show you how we went about this. So the first thing we're doing here is you'll notice my block number 1 is a work offset call. If I go into that data block, the first thing it's going to ask is, what is your active offset? You can use this drop-down menu to choose any of your work offsets, G54 through 59, or any of your auxiliary work offsets if you need any of the additional 93 work offsets that are available down here. So all we're simply doing here is telling it which offset do we want to activate, which one are we going to use. And it is showing me the offsets that I have here for my G54. And then my next block, I have a mill circle. So if I wanted to duplicate this on my different work offsets, I would simply just go in here, copy my data blocks, paste them into the program, and then just go change my work offset. I'm going to change my active work offset to G55. While I'm here, I'll just go ahead and paste this and set up G56 as well. You see we do have all 3 work offsets defined. So now when I draw this part, you're going to see this here. So this just allows those that are familiar with using work offsets to use those work offsets conversationally. This makes it nice if you're jumping back and forth between NC and conversational. Maybe you have a corner of your vise set up as your G54 and you always use that as G54. You can now call that into a G-code or conversational program. Also very useful for those of you that have probing systems on your machine. If you wanted to start your program and maybe go in and probe 4 or 5 different parts in the table and store each one of those locations, you could store it to the work offsets and then just call those work offsets back up in your program as needed. So a very useful tool. There are 3 things that need to be met in order to use the work offsets. One is you have to be running universal rotary program type. I would assume that the majority of you probably are running universal rotary and don't even realize it. There's a little bit of a confusion out there. Some guys believe that you have to have a rotary machine to run a universal rotary program type. That is incorrect. You can run the universal rotary program type on any machine that we offer. I would highly recommend running that as your default program type because it does allow you to do a few more things, this being one of them. So you have to be in universal program type. You have to be running absolute tool length for your touch-off method. If you've purchased a machine in the last, 5-6 years, this has been the default. So the majority of you probably are running absolute tool length. And we will be doing a session here shortly on the absolute tool length for those of you that are not and maybe considering the switch over to absolute tool length. And the third thing is you have to have your NC program type set to ISNC or industry standard. That sounds a little odd, because we're in a conversational program here, but now that it is utilizing some of that NC stuff, it just needs to make sure that everything is kind of on the same page. So the 3 things: universal rotary, absolute tool length, and industry standard NC programming type. And then you can be able to use your work offsets there as well. So if I go in here and take a look through the work or the miscellaneous data blocks, you'll notice that there's a few things that we haven't went over yet. And most of it pertains to probing. We're not going to go over that in this session here. That will be gone over in a probing session if we ever choose to do that here, since it only pertains to those who do have probes on their machines. But if we start to look through here, there are a few of these miscellaneous data blocks that the standard user is just going to completely ignore. They're not even going to, put the effort into messing with. The lube cycle up here at the top is one of those. This is essentially for backwards compatibility. If you have a new machine and maybe you're making programs for some older machines, that that you may have had to program the lube cycle, or maybe you wanted to program some additional lubrication. You can do that here. The modern machines are not affected by this. This is essentially here for older machines that don't have the more advanced lubrication systems. So lube cycle is one that most users are probably going to ignore. This insert data block is one that the majority of our users are going to ignore as well. This is mostly for our engineering team, to be honest. There are some features in here for, if you're taking a conversational program, and in the past we had a feature for converting to G code. This was primarily for that. So going to be pretty much ignored now. And then we go back here, you see we've already discussed these here. I do realize that when I was in tool optimization, I forgot one thing, so we'll go talk about that. But for the most part, this is your miscellaneous data blocks. A lot of pretty simple features all kind of laid out here that can make a pretty big impact on how your machine runs. And since I left something out in the tool change optimization portion, let me jump back to that real quick. I apologize for that. If I go to that tool optimization data block, these two parameters that I skipped over before, the maintain operation level 1 and 2, what these allow you to do is still try to optimize your tool changes. However, if we turn these to yes, we're basically turning them on. We're telling it that we need to maintain the operation order. So in other words, I need to rough block 1 before I rough block 2, and then before I rough block 3. So I need to rough in order. If you turn both of these parameters to yes, or turn them on, you're basically telling it to optimize your program, but you have to rough all the blocks in order, and then you can go back and finish all the blocks in order. Where this is useful is if you've created a lot of pockets or something, and you're roughing with one tool and finishing with another tool and all those data blocks, you can very easily just set these to yes and just separate that roughing and finishing pass to make sure that you rough all the blocks in order. If you had a pocket that was, let's say, inside of another pocket, this would guarantee that that first pocket was rough before it tried to do anything to that second pocket. For the most part, these are not necessary, and the majority of the people that use tool change optimization never set any of these. They just go with the default optimization. So that's the parameters of the tool change optimization. I'm sorry for skipping over that earlier. And that there is our miscellaneous data blocks. I know we covered a lot of
unmuted
pretty quickly there. We'll turn it over to Mike and see if there were any questions that came up through the presentation.
Yeah, thanks, Jason. Good job. We've got a couple of questions here. Let me scroll back up to find them. A lot of them telling us that we had lost the screens and so forth. So if you enter a change parameters block, the next cycle, is it going to use the data entered in the block or go back to the original part setup for the program? You did answer that, but you might want to cover that again.
Okay, so either or. So I kind of zoned out there. I wasn't sure if this was change parameters or change part setup, but they're both going to behave the same. Either of them, essentially what it's going to do, like let's say for the change parameters that I have up here on the screen, is going to go off your original parameter set until it gets to this change parameter in your data block. It's then going to go off of this parameter set from this point on in the program. So you've essentially just changed your parameters. So it will go off of that parameter set for every data block past this until it gets to another change parameters, or until it gets to the end of the program, which then it just goes back to your default. Same thing for the change part setup, is it's just going to go off your original part setup in your program until it gets to this change part setup in your program, and then it's going to go off of this part setup until that is changed or until you get to the end of the program. So both of those data blocks will affect everything that follows or until it sees another change parameters or change part setup data block.
Okay, good. So we only had one more, and it's more of a comment, but it was talking about using recovery restart with tool change optimization active. So you might want to cover that a little bit about how
Okay.
that behaves.
Yeah, that's a very good question. And I'm guessing the whoever wrote this has used this in the past. When you are using tool change optimization, starting a program can become a little bit more tricky. You know, most of us are used to just going in. If we want to start on block 4 in our program, we go into the auto screen. We tell it to start on block 4 and run program. Well, that's can't necessarily be done with tool change optimization because the control has to process everything that's been done to figure out what order to start there or to machine things. So anytime you're using tool change optimization, when you go to start anywhere other than the beginning of your program, make sure you go in and still tell it to start on block 4 or whatever you want, but use the recovery restart. That allows the control to go back through, process everything that's been done, and figure out where it should pick up with that restart. So that's a very good comment. Thank you for bringing that up. I must admit, when I first started using tool change optimization, it took me longer than I should probably admit to start using that recovery restart. I really struggled with that, trying to use my older methods of just starting the program. As soon as I started using the recovery restart, a lot of those issues and inconveniences kind of went away. So that's a good comment there. Thank you for that.
Yeah, I've also found that is a good time when we can use the parameters, program parameters to turn that on and off. I've done that as well.
Yeah.
All right, so we have one more that came up here. So I can use the change parameters to stop it from Z up during interrupt when using a slitting blade or tap. Then turn it
Correct.
back to normal when drilling. Yes.
Correct. And that is a very common use for that, with one exception there. You mentioned tap in there. You don't need to do it for a tapping cycle. Anytime the control is tapping, it knows that it can't interrupt. So if you hit that interrupt button while it is tapping, that interrupt little LED, the little light will just kind of flash at you until it gets out of the hole, and then it'll retract up. But other than that, yes, it's pretty common if I'm using a slitting saw or key seat cutter or anything like that. I'll put a change parameters block in just to disable that interrupt cycle Z retract. And then as soon as I'm done, I put another change parameters block in just so I can enable that functionality again because I use the interrupt button so often.
All right, very good. Well, that seems to be the end of the questions that and comments that we received.
Okay, well, I've got one more thing to share here with you. We got sent a document by one of the people that was in the last session. This is from Doug Casper. He said some of you may know him as Dave E. Jones on the Facebook machinist group or users group, I guess I should say. If you're not familiar with that, and you have a Facebook account, go check that out. Just a lot of Hurco users there that post information and questions and those kind of things. But he sent something in. It seems that Doug or Davey Jones does a lot of training. I'm assuming of his guys or some other guys. And he wanted to show us his initial setup. And I took a look at it, and it's a pretty good setup. So I wanted to just share that real quick, and I appreciate you sending this in, Doug. But this is how Doug starts his programs. Every program will start with these 3 blocks. And again, this is just his preference. I thought I would share. So the first thing he does is he starts with a comment block. And he uses this to basically give information to any operator that may use this program in the future. I really like this. I use the comment block quite a bit for this kind of thing as well. I've just never really standardized on it. But I thought that was a really good idea. Just start with the comment block, and you can tell them things like, use the 1/2 inch parallels, or use fixture number, whatever, anything you want to pass on, you can put that in your comment block. So I thought that was a good block. I typically use the description section in our program parameters, but I kind of like this better. The second block he puts in is a change parameters, and I have to admit, when I first saw this, I didn't know if I agreed with it, and I don't know if it was in the email that Doug sent or if it was something I read here, but he puts a change parameters block in so that he can set the parameters for that program, which my initial thought, well, this is a second place I have to go and then adjust my parameters. Well, Doug's argument or explanation of this was this prevents someone from accidentally going in, changing a parameter in your program parameters that's going to affect a already proven program. So it's just another little level of safety for a proven program. And I kind of like that. It took me a second to find how he's using it, but that was kind of nice. And then his third block happens to be a comment block, which will explain what's going to happen in the following block. So I'm assuming that he uses this. He may post it in between multiple blocks in his program just to explain what's going on. So I thought this was a nice thing as well. For anyone that's walking up, getting ready to run one of Doug's programs, they can open it up and just kind of work through the conversational program, and it'll tell you everything that's going on there. So he then has really nice layout here as well, but he just kind of has examples of those data blocks. So I appreciate Doug taking the time to send that in. He saw what our session was going to be over today and decided to share this. So I really appreciate him sending that over to us. Say, is anything else came in, Mike, or is that look like we're wrapping it up?
We did have one comment that is going to turn out to be a good enhancement request. Okay. I won't mention that, get everybody all excited, but I did think it was a good idea, so I'm going to write that up as a request for an enhancement because it would be a good thing. Cool. Again, we are recording this, so everyone who attended today or those who weren't able to log on because we did go over our registrations, we'll go ahead and send an email out to everyone to be able to get this recording. And we are adding all of the recordings for these first two and all the upcoming webinars will be on the website under the Hurco.com. Go to the support tab and you can go to a section for webinars and you can watch these there as well.
All right, maybe, so I think we can probably end the recording here and then we can leave this open for any other questions that others may have.
Using a 1, 2, 3 block.
I'm sorry?
Well, someone's unmuted, but I can't find out who.
Okay, so for those of you that are still there, we're going to go ahead and end the recording, and then we'll just kind of leave this open. You can use your